In unit number 3, we are studying distance and displacement. It is a very important unit. We are learning two physical quantities, distance and displacement. So, when you study distance, which are the things you must study? First is, what is distance? Distance is path covered by the object. Path covered by the object. So when an object travels, it can travel different path. For example, if you are moving from Umtata to East London, you can reach East London in different ways by using different roads. So you are taking different path. Each path has its own distance. So path covered by an object is known as distance. So the path can be a straight path, a curved path, or a random path. It can be anything. So path covered by the object. Path covered by the object is known as distance. So when you travel to a place, you are covering a distance. And you can take any path. And the path covered by the object, it is known as distance. Then how will you measure distance? It is measured by unit meter. It is measured in meter. It is measured in meter. Then, is it a scalar quantity or a vector quantity? It is a scalar quantity. Why? Because it has only magnitude. Because you can reach a place by taking different path. So there is no need of mentioning the direction. We are not mentioning the direction. By using any path, you can reach the place. So there is no need of mentioning the direction. So distance can take any path. Distance can take any path. So it is a scalar quantity. It is a scalar quantity. It has only magnitude. It has only magnitude. It has no direction. So it is a scalar quantity. For example, from Umtata to East London. For example, distance is 250 kilometer. Here 250 kilometer is the magnitude. So when you express distance, there is no need of saying its direction. You can represent distance completely by its magnitude. There is no need of saying the direction. There is no need of saying direction. So if you take another path from Umtata to East London, the distance will be different. Distance will be different. So when you take different path to East London, you can travel, you will get different distance. You will get different distance and the magnitudes will be different. So there is no need of saying there is no need of saying direction when you study distance. Distance means it is a path covered by the object. It can take any path and that path is measured in kilometer. Or when you do the numericals, you must use the unit meter. It is a scalar quantity. Why it is a scalar quantity? Because when you define or when you explain distance, there is no need of saying direction. By simply its magnitude, you can explain distance. Next, you are learning another physical quantity, distance. Another physical quantity, displacement. Another physical quantity, displacement. What is the difference between distance and displacement? Displacement means change in position of an object. Change in position of an object. That means when you explain displacement, you are considering the initial position of the object and the final position of the object. For example, you are traveling from Umtata to East London. Then you are coming back to Umtata. Your displacement is 0. What is the reason? Your initial position in data and finally you reached data. So there is no change in position. There is no change in position of an object. So your displacement will be 0. So when you calculate displacement, you are considering the change in position of an object only. Change in position of an object. Displacement will not consider the path covered by the object. It takes only the change in position. And the change in position you can mark by a straight path. So if you have a path like this from A to B, you can reach from A to B by a straight path. So this will be the displacement, because the change in position takes place in a shortest path. The change in position takes place in a shortest path. That's by a straight line or a straight path. That will be the displacement, and this will be the distance, because distance is the path covered by the object. And when you calculate displacement, you are considering only the change in position. Change in position by a straight line or a straight path. So that gives you displacement. Then displacement you are measuring in meter. You are measuring in meter. Displacement is a vector quantity. Displacement is a vector quantity. What is the reason? Because when you calculate displacement, you are taking direction. Because when you by using the direction only, you can take the displacement. So when you define displacement, displacement is the change in position in a straight path. In a straight path. So the path should be straight. So there should be a specific direction to that destination. To that destination with the shortest distance. So you can reach East London by taking different distance, or by taking different path. But there will be a shortest path. There will be a shortest path to reach East London by a straight road. But practically there will be no path like that. So you can reach East London in a shortest way if there is a straight road connecting Umtata and East London. But practically it is not possible. So that path makes what? That will make displacement. So displacement simply means change in position of an object in a shortest path. So that gives displacement. So when you calculate displacement, there should be a specific direction in order to reach the destination with a shortest path. So there will be a direction. So that's why displacement is a vector quantity. It has a direction. For example, this is A, this is B. You can reach from A to B in different way. In different way, you can reach B. You can reach B in different way. But in order to reach B, there will be a straight path. There should be a straight path. And that straight path gives displacement. And that shortest path gives the displacement. All other paths, they are distances. So from one place to another, there will be only one displacement in a straight path. So this is the displacement, and all others are distances. So in order to reach a place, there will be a single shortest path, and that path gives you displacement. So that's why displacement is coming as a vector quantity, because in order to get displacement, you should travel in a specific direction. That means a straight path. In order to get displacement, you should travel a straight path in a specific direction. Then only you will get displacement. That's why it is a vector quantity. Another example I can give you. If an object is traveling from A to B, then reaching C. For example, this is 3 meter, this is 5 meter. So initially the object was at A, finally the object is reaching C. So what is the distance and displacement in this motion? So distance will be distance equal to AB plus BC. That is the path covered by the object. 3 plus 5 equal to 8 meter. But in order to reach C, there is a straight path with the minimum distance. So that gives displacement. This is the shortest path to reach C from A. That gives you displacement. So this is the displacement. So displacement simply means it is a change in position in a shortest path. So from A to, you can reach C from A in this path. This is the shortest path to reach C, and that will be the displacement. So this you can calculate by using Pythagoras theorem. By using Pythagoras theorem, you can calculate this displacement. So what is the reason? This displacement is coming as hypotenuse of the right angle triangle. Another example, if an object is traveling in a circular path, it is starting from here A and reaching A, complete one circular motion. Then what is the distance here? Distance equal to circumference of the circle. Circumference of the circle means this is radius of the circle, and this will be 2 pi r. So this is the path covered by the object. That is the circumference of the circle and equal to 2 pi r. Then what will be its displacement? Displacement will be 0. Displacement will be 0. What is the reason? There is no change in position. Initially the object was at A, finally the object reaching again A. So displacement will be 0. So this change in position, there is no change in position of the object. So the displacement is 0 there. But the distance is 2 pi r. That is the circumference of the circle. Then if you take the semicircle, if you consider a semicircle from A to B, what is the distance? What is the distance? Distance is half of the circumference of the circle, that is 2 pi r divided by 2 equal to pi r. That is the distance covered by the object. Then what is the displacement? Displacement equal to, you want to reach B in a shortest path. So this will be the shortest path to reach B. So initially at A, finally at B. So change in position of the object in a shortest path, that will be the along the diameter of the circle. So that value will be 2r. That is the diameter of the circle. So 2r gives the displacement and distance gives pi r. So this gives the pi r. That is the semicircle. Then from A to B, you can reach B in a shortest path, and that is the motion along the diameter, and that diameter is 2r. So for this motion, distance is pi r and displacement is 2r. Then if you consider the upward motion of an object, here the object coming down and it is moving up. This is 10 meter A to B, then reaching C. For example, it is 5 meter or 6 meter. 6 meter. Then what is the distance of the object? Distance equal to what is the total path covered by the object? It is from A to B, then upward motion. So 10 meter plus 6 meter equal to 16 meter. Then what is the displacement? What is the displacement? What is the displacement? So initially the object was here. Finally the object is here at C. So this gives the displacement. This is the change in position of the object. Initially it was at A, finally at C. So change in position is between A and C. Between A and C. So this will be 10 meter minus 6 meter equal to 4 meter. So displacement will be 4 meter. So when you calculate distance and displacement always taking change in position. Change in position. So here the change in position is only 4 meter because initially the object was at A and finally the object at C. So the change in position is only 4 meter. But the distance is what? A to B, then upward motion. So it will be 10 plus 6 meter. 10 plus 6 meter. It is 16 meter. So here we are using distance and displacement. We are finding distance and displacement. Here both are different. Because displacement is a vector quantity. Distance is a scalar quantity. And one thing you can remember, the downward we are taking as, for example, downward is taking as plus, upward is taking as minus. So 10 meter you are considering as plus because downward you are considering as positive. And then upward motion, that is 6 meter, you are considering as minus 6 meter. So when you subtract this, you will get what? 4 meter. So here the downward motion you are considering as positive. So 10 meter comes plus 10 meter, and the upward motion you are considering as minus. So minus 6 meter. So that's why you are getting 4 meter. Or simply you can calculate displacement by taking the change in position. Initially at A, finally at C. So the change in position of the object is 10 meter, that is the total here, and 6 meter here. So the difference will be 10 meter minus 6 meter. So it is 4 meter. So this is all about distance and displacement.